So we have prepared today a presentation for you about 3 different grinding machines. The first is WPG7, the next is W11 CNC, and the W11 Evolution is also part of our presentation today. So now let's start with the WPG7. Here we can see a nice picture from WPG7 in the middle of the slide, so you can see the compact design. And next to the picture we have some important information numbers for this machine. First of all, we can use on the machine corundum and CBN grinding wheels on the machine. We can have grinding wheels up to 500 millimeters in diameter and 18 millimeters width. Cutting speed is limited up to 50 meters per second. And automation is possible. We have some standard solutions for the WPG7, and we can have also customized solutions. So we'll see later on some slides and information about automation. The floor space is 1.8 to 2.4 meters. So this is without any additional equipment like cooling system, exhausting, and automation. But even this is a very, very small floor space for this machine. Control system is FANUC control. Then we have workpiece lengths maximum 250 millimeters and center height of 100 millimeters. So means swiveling diameters up to nearly 200 millimeter. Maximum workpiece weight is 30 kilogram. So here we have a little animation about this machine with an example of a gear shaft driven by a standard dog driver, in this case manual loaded. So we can see here an angled wheel declined on the 30 degrees. We grind 3 diameters, one, let's say, normal diameter, and the third one is the tip or the OD diameter from the gear part. So in this animation, we can see every 3 diameters separately, but it's also possible to have a profiled grinding wheel to cut all the diameters together. So I think this is a nice animation to get a first impression about the machine. Then a short movie about a test cut we have done recently. This is a piston for a hydraulic pump. On the left-hand side, you can see the center point in the headstock with the coated surface. Coated surface because to have a good torque for driving the part. Then now we can, with the grinding wheel, completely plunge cut grinding the whole length of the part. And additionally, the in-process measurement system, which gives us the good quality of the diameter tolerance.
Andreas, if I can ask you shortly here a question. If we look, there is the radial, this huge hole. Is there influence? Is there influence today? Is interrupted cut?
Yeah. No, in this case not. It's always when you see this on a drawing, you think maybe there is something. That's why we make also some test cuts, and during this test cut we realized that we don't have any problem with this shape of this part.
Okay, sounds good. Thank you.
Yeah. Here we can see some information around the machines. On the left-hand side, we have the maintenance door from the back side. So we have a lot of maintenance doors around the machine to have a good access. We will see later on a picture of that. How does it look like? Then we have the coolant outlet on the back side of the machine. Then we have the main switch also on the back side. Coolant inlet, input coolant is also on the back side, could be also on the top of the machine. This depends on the frame conditions at the customer. Then we have the electrical cabinet. Then we have a lubrication unit. Air condition is optional. We normally don't need this. This is a special package. Yeah. Then we have lubrication unit, also a very compact design internal in the housing. Lubrication for guideways, X and Z. Then we have a coolant unit for the grinding spindle and a pneumatic unit also complete integrated in the housing. This is a very compact design. Then another maintenance door from the side, and from top we have also a maintenance door. And finally the operating door in the front of the machine to load and unload and operate and set up the machine, and the operating panel.
Andreas, if I can hear you're showing the accessibility. You for changing the grinding wheel, you do this from the front side, or what is the best way to change the grinding wheel?
No, the grinding wheel changing is basically from the right-hand side or from the back side, maybe with a handle from the top. So we have different solutions. It depends also on the possibilities on-site customer. If there is a crane, then we can use the handle. Sometimes we have also use other things outside of the machine. So there are, depending on the wheel is angled or straight, different solutions for grinding wheel changing. But here we can see on the right-hand side the picture. This is very nice that you can see if you replace these panels, you can have a very good access to the machine, even if it's very compact. Yeah. Then spindle configurations. We have on the left-hand side, we have one straight grinding wheel. It's one possibility to have on the machine. Here we can see this also on the picture in the middle. So we can have plunge cut grinding for one diameter. We can also have multi-plunge cut grinding along the part and traverse grinding. Or we can have profiled grinding like here and to make several diameters on the workpiece in one plunge cut grinding, including measuring system. Yeah, and then on the right-hand side, we have the angled one. So we can have one or the other. We cannot swivel the grinding wheel, so we have to do this during discussion with customer. When we have drawings, when we have requirements, we will select together with customer what is the right spindle configuration for the machine. You can see it also on the right-hand side, the angled one.
So, Andreas, it means if you have to do face grinding, or shoulder grinding, we recommend to have the 30 degrees bevel grinding position, or?
Yeah, the main reason is the shoulder grinding. So it's possible to make it with a straight wheel, but we have to dress the side of the wheel, and we have a kind of a plunge cut grinding. So this is not the really perfect grinding for shoulders. That's why an angled wheel is much better. Also, when we have a higher shoulder, then we get a good run out, a good surface quality, and the shape of the surface is also different. That's why if we have to grind shoulders with good qualities and higher shoulders, then it's better to have the angled solution. Yeah.
And Andreas, there is also coming the first question out of the audience. We will show later something regarding automation, but we would like to answer this directly. Yeah. There's the question, can we add a robot for the grinding machine for automation or loading the machine?
Yes, for sure. Yeah. We can have outside of the machine, we have the gain loader, which we will see later on. We can, with the gain loader, we can bring out the machine, the part outside of the machine. Then we can have the takeover stations or any customized solution outside of the machine, which supplied by customer.
But we can also directly loading inside with the robot directly inside the spindle from the front side. Yeah. For example, with a normal robot or also with a cobot. Yeah. So that's a possible solution. That's also offering.
Yeah. Also possible. We have automated operating door. This is no problem. We can put the robot system in front of the machine. It's up to the customer if they access to the machine for setup. It's okay or not. We can move it, but this is also possible. Yeah.
Okay.
So here we can see this this automation system. This is a view about access from the machine. Here we have the machine bed, and on the front side we have the Z axis. This is in front of the operator, is moving in Z axis, and this axis take the workpiece between centers. On the left-hand side, we have the workhead spindle for driving the part, and in the opposite, we have the tailstock, with also a center point to clamp the part between centers. And then we have X-axis, which takes the grinding wheel to make the diameters. And additionally to that, we have the gain tree loader, AH1, to bring in and out the part, and the AV1 is for picking up and lay down the part on the gain tree, on the storage system, automation system, whatever is there. Yeah, then we have some information about the sub-assemblies itself. So we have the work headstock here. The RPM is 2000 rotations per minute. We have a tooth belt drive. So the tooth belt especially to have an orientated spindle stop. If we need it maybe for loading, unloading. If we have chucking part, we have special position for loading, unloading. Then we have an adaptation of MK4 as a standard for taking center points. We have also the possibility to have a fixed center point or a driven center point for much higher quality. We can fix the center. We have chucking system. It's also possible, and clamping jaw as well. Yeah. The bearings are grease lubrication and with a good high axial and radial stiffness, because to have the possibility to have chucking system also on the workhead stock. Then the next one is the tailstock. It's a cool tailstock with a stroke of 30 millimeters. Adaptation is MK3, and we have a cylinder correction of plus minus 40 microns. This is the handle on the back side of the tailstock, and with the handle on top of the tailstock is the manual operation to open and close it. And if we have an automated solution or a foot pedal, then we have an additional pneumatic cylinder on the back side on the tailstock. Then we can have also the automated operating.
Andreas, you're showing something about the tailstock which is available. There came a question which is a little bit tricky, I think, because that's a question which we get often. Can we offer WPG7 so-called with a synchronized tailstock?
No, this option is currently not available.
But currently is the
yeah, but we will see how we can we can set, let's say, improve the machine or whatever. But currently we can have a turning center which we put in the MK3 tailstock in the adaptation, but we cannot drive the tailstock side.
So it's not a driven.
It's not a driven.
Driven at the moment, not in no option.
No.
But we're looking for this. So if it's, and also if you have there some critical things, send us the drawing of your application, and we double check. We double check if it's really needed or it's only nice to have for this application. Yeah. So we do also really accurate grinding operations without a synchronized tailstock. Yeah. So please, anyway, feel free to send us this request to us.
Yeah. So here a picture for the grinding wheel. So we have a motorized grinding spindle. This grinding spindle has power of 14 kilowatt. The size of the wheel is 500 by 80. It could be also a little bit wider with this more power, but this has to be decided during this technical discussion with customer what is possible and what we can realize. We have an adaptation for the spindle flange of taper 1 to 4. Then we have water cooling, sealing air, and automatic balancing. Yeah. On here we can see on the left-hand side the straight wheel and also the angled one. Hello.
Okay, then.
Sorry.
Now Andreas stating already that we can use CBN and corundum grinding wheels, and for this is of sure important that we have dressing systems on the WPG7 machine. And if you see here, on the left side, you see the dressing blades or the diamond, it's for the corundum grinding wheel. And theoretically, you can also dress here CBN with this solution, but the wear is too high. So for the best dressing results, if you want to use CBN wheels, you need a dressing spindle, which you see on the right picture. And there is, it's necessary for the best result of CBN dressing. That's an option. So if you are knowing already that you want to use as well CBN grinding wheels, we recommend highly that you have the dressing spindle we are mounting it on the tailstock slide then. Yeah. So that's the point from this. And that's
a few words from my side. The dressing could be also on different positions. It depends on the inclined or the straight wheel, but this is also something that we are doing in the project management and during discussion with customer to select the best solution for customer. Yeah.
Andreas, so the audience is really active and asking questions, a lot of questions.
Okay.
That's where we see later in some slides, but anyway, I will place the question already. Does the measurement unit provide feedback to the control for automatic adjustment, diameter, or size?
So what we have on the machine is our in-process measurement system, yeah. And this in-process measurement system is continuously measuring the diameter of the workpiece we grind permanently, and if we reach the programmed final diameter, then this measurement system stops the grinding process. Yeah. So this is what we have on the machine. Yeah. So so that's why we don't have. I don't know exactly what does it mean. So there is no feedback about different sizes.
We have an in-process.
But the in-process measurement system is perfectly to have a good current quality during the grinding process, especially for automated versions.
Okay, I hope this question is answered already, but you will see also later our things which we can do there.
So here we have a picture from the machine, also without housing, from the back side. What we can see here is it's a nice view about the separate axis. In the front side, you can see the x-axis with the blue-colored grinding unit on top on the x-axis. So this is separately mounted directly on the bed. And on the opposite side, we have the z-axis, which is also directly mounted on the machine bed. So this gives us a very stable, flat and compact design, which results also in a very good quality. This is no cross-slide or whatever. Here a picture from the guideways itself. We have grounded profiled guideways in both axes. Then we have servo motor, ball screw spindles and glass scales. Also this, in addition to this design, is a very good base for good quality of the machine. Here are the measurement systems. On the left-hand side, you can see this is this in-process measurement system. We can see it later on also on the video. So this measurement system moves to the workpiece parallel to the grinding wheel. We start to grind and measure at the same time. And then the diameter goes smaller, 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 and we reach the final diameter. The measurement system says stop, and then we stop grinding. And with this unit, you can grind up to 1 to 2 microns.
Yeah, and if I can add something, you can program it. You can say also on the higher tolerance limit or on the lower tolerance limit.
Yeah, normally we
tolerance limit. So you can tell the measurement probe as well when they should.
Yeah, we go in the middle of the tolerance.
Normally, but it's you can also playing with this with the tolerance limit thing.
So on the right-hand side, we can see a picture of the axial positioning system. This is important for also if the center holes has some tolerances, and the position of the workpiece on the center points is then different because the center hole is a bit bigger or smaller. The set position of the workpiece is not always the same. Then we move in with this measurement system, touch the shoulder, and make the correction of the correct workpiece in set, and then we can grind. We start to grind because this is important if we grind shoulder. That we don't have any collision or we far away from the shoulder when we start to grinding. Another useful system is also our automatic balancing system. So this system starts immediately when we start the grinding wheel turning. It starts to compensate any unbalancing on the system. This is especially good for a good surface quality and also for the lifetime of the bearings. Especially for random grinding wheels, they are going smaller and smaller during the dressing. The CBN not so much, but it's going smaller. They change the weight of the wheel, and maybe also the balance is changing. And sometimes, if the machine is standing a lot, sometimes for hours or whatever, then some water is maybe inside of the wheel, and then we have also unbalanced in the grinding wheel, and that's why it's a very useful unit, especially also for automated operation or production. The next useful system is a gap crash control. This is a sensor which is control the connection between grinding wheel and workpiece. So as soon as we reach the workpiece with the grinding wheel and have connection, there is a signal for the machine, and then they can work with the signal. We have here two basic reasons for this technology. First is the crash control. So if the stock on the diameter is higher than expected or higher than we programmed this in our system, in the programming system, then we recognize this because we go with a higher feed rate to the starting point for grinding and recognize, oh, there's too much stock. Then we stop the process immediately and avoid a big crash. This is one. And gap control means that if the stock allowance is too less, then we start normally much too earlier to grind. We grinding air, let's say, yes, air grinding, yeah. But if we don't have any contact, which we are expecting, then we can have a higher feed rate and move to the real stock and start then to grind. Saves, so let's say 1, 2, 5, 6 seconds per part. And if you produce some 1,000 parts per year, you can save a lot of time and money.
Okay, then we're speaking about a CNC machine, which means we have also a control system. And here we selected Fanuc as the supplier. Like, many of our turning machines using as well Fanuc control. So for this small machine, this was a good selection. We have to go with the Fanuc control. And if you look, that's our standard. You can use in USB. If somebody want to use USB, it's not so easy at the moment, or with the cyber security. But you can bring in the program, or you can make program management with the USB, but offshore as well with a network interface. And what is much more important is that you have a really good dialogue program where you can do easy dialogue programming, or you can as well be in ISO programming. So we have different grinding cycles available. Yeah, if you see here, the overview, that's the basic menu where you can set up the dressing. Yeah, you can set up the measurement. Yeah, and then you can select, okay, I want to do outer diameter grinding. Yeah, and then you see the cycles. There you have then the cycle for plunge grinding. So you have only to give all the information which you have from the grinding wheel, from the workpiece, and then the program getting easily programmed. So it's easily programmed. I don't know if it's so easy that Andreas and myself can program it, but the guy which working on a CNC machine, for them it's really easy to program the machine with our dialogue program. Okay, that's the short input about the control system. If you want to have more information, visiting us, and then we can show you all the menus on the machine directly.
So, okay. So here we have animation with automation system. This is our standard solution. Yeah, for our automation, we have an in-feed and out-feed conveyor as a storage system, and here we can see the loading unloading. This is a horizontal gantry loader with two pneumatic strokes, grippers. You can see here the loading unloading process. So measurement system goes back, finished part take over out of the clamping, in the raw part new clamped now, and here we pick up the new raw part and go back to the work area. So this is a standard solution from our side, and as mentioned, we have some different solutions to connect the machine with several automation systems. Here is a layout with the complete package. So we have a coolant system. You can see on the picture on the left-hand side with coolant paper band filter on the back side. Then on the right-hand side, you can see the fans. It's not the plate cover like we have seen on the animation, but normally we can have also the fans around this. The sucking system is also on, and we have for this complete package 3.7 meters by 4.2 meters floor space for the complete package. Yeah, I think this is a very compact, compact design for this production system here. So then we have best samples. One is this hydraulic piston we have seen shortly before. So here we have to reach with an OD grinding wheel 500 millimeter by 43 millimeter and a workpiece diameter 33.3, a tolerance from totally 8 microns. We have an in-process measurement system also on the part. You can see this also on the picture. And what we have reached here, the quality, we reached a CMK 1.67 for this 8 microns. Cylindricity 5 microns. RZ was required from customer in 2 values, RZ 0.5 and RA 0.32. And this whole grinding process took 21 seconds without loading, unloading, with a stock of 0.25 millimeters. So I think this is a good quality and also a good cycle time for this part. Here you can see the video, including water. This is directly from the grinding.
And Andreas, if I can interrupt you here shortly, during the video here, we see the cooling. The cooling is as done by emulsion. How it looks like if you some customers want to grind as well with oil. How is it's also possible on this machine?
The oil is for the machine, no problem. Yeah, so we can use oil as well, but we need all the fire protection system around the machine. So special coolant, distinguishing systems, pressure relief flaps, and such things has to be. It's mandatory for oil grinding to avoid any problems. So this is not necessary, and then we can use oil without any problems.
Thank you.
So here we have the next example. This was all plunge cut grinding with one wheel. We have on one wheel 2 possibilities for grinding. This it was dressed. The gear part was dress free, so that we have only two diameters for grinding. The left-hand side is 12 millimeters with an interrupted cut. On the right-hand side, we have 10 millimeters, also with an in-process measurement system. And here we have also to reach this 8 micron tolerance. We reached this 1.67. And the concentricity was also 10 microns. And then we have on both sides different values for surface quality, RZ4 and RZ3. Also, this was reached from our side. And the total cycle time was 25 seconds, including loading, unloading. And the stock allowance was also 0.2 millimeters on diameter. Here we can see the video. This is a nice solution. You can see here a video which we have a combination of the WPG7 in combination with a robot cell which supplied from a customer. Yeah, this is a good example for automation, flexible one. We have as an interface, we have a takeover station with 2 prisms. So we lay down and pick up a raw and a finished part at the same time. You can see it here. And then the robot system take the part and do the work for the robot cell. And we go back to the work area and machining. So you can see raw part right side, new finished part right side, new raw part on the left side. We go back to the machine area, loading, unloading, and then start to grinding. You can see here the profile grinding wheel with in-process measurement system. And here you can see a rotated center point, yeah, with a rotating control. So if the workpiece will stop, we will recognize this because of this bero, this sensor, and then we can stop or react accordingly. Yeah.
So that's it's not a synchronized, but it's a controlled.
A live spindle, which is turning with the part. And if the part has some problems, then they stand still, then we recognize this. Yeah. So this was a nice project, a very good example for connection customized solutions with the WPG7. Yeah, here's some pictures about some sample parts. For sure, there are a lot of more different parts all over the world we can realize on a WPG7. And finally, complete numbers. As we discussed already, so swiveling diameter 200 millimeters. Then we have 250 millimeters part length, center height 100 millimeters, distance between center 380 and so on. So I think these are good numbers for this small machine.
Okay, that's the overview about the WPG7, our smallest CNC grinding machine. And there we came to the W11 CNC machine. Here you see already on the pictures different application, outside grinding, and with you see also that the B-axis is there. So, and if we look, I told you already, external and internal grinding possible. How we can do this? We do this because we can have a B-axis where we can do the stepless positioning. As is like the small machines, we are able to grind corundium and or CBN grinding, yeah, and as well automation is possible. You can use gantry, you can use robots. So there we are really flexible about the solution which we can provide to you. Yeah. Small overview about the technical data is what is important. We have 3 different grinding lengths from 650 to 1.5 meter. And the center height is in the standard 200 millimeters. We can optional 250 or 320 millimeters center height. That's the short overview about the technical data which we have on this machine concept. Again, the picture about several applications, but there we can jump over because you see it later on. Here it's important. That's the spindle configurations which you can select, yeah, which you can discuss with our sales guy, with our technical sales experts. What is the correct or the best configuration for your application? We're starting on the left side with OD grinding. You can have a spindle only on the left side or on the right side. If you have to do different applications, you can have also 2 grinding wheels, OD grinding, both on the same side or on the opposite side. So there you're using then the B-axis. And if you need more flexibility, you can have also combined external and internal grinding possibilities. So, and for the internal grinding spindle, you have also the option to select between belt-driven or as well between motorized internal grinding spindles. The B-axis, I stated already, it's direct-driven torque axis with a high resolute measurement system, including brake systems, and it gives you really a high flexibility on the machine. So, Andreas, please continue with the details of about the components.
Mm-hmm. Yeah, thank you. So on the left-hand side, on the top, we see the work headstock. The work headstock has an adaptation of MK4. We have also the possibility to mount any flange for magnetic blade or chucking system, or some special chuck with a pneumatic or also an hydraulic clamping cylinder. But hydraulic will be separately a small unit necessary because our machines are always completely hydraulic free. We have the option also for MK5. MK5 is the same size like the MK4, but only with a bigger adaptation for the tool, for the clamping system. And then we have MK6. Optionally, this is a bigger headstock with different bearings. And then we can have a load for part, including chucking system up to 150 kilos if you have some chucking parts without a center point from the tailstock. So it's very, very a lot of weight we can load here on this.
Yes, there is also one more question. How to control both diameters as the grinding wheel will be different on both diameters? So I don't know if they're asking. I don't understand 100%. I understand it completely, but it's done on the bludge grinding.
No, yeah, this is basically one wheel.
Yeah.
We dress the whole wheel, but only we make we cover out the part for the grinding, for the gear shaft part. Yeah, but and finally this is only one diameter, and we dress both diameters in the same time. That's why it's more or less the same. Yeah, that's why we have always the same quality. Yeah, this is no different wheels. If we have different wheels on different units, then it's difficult. But we have compact one wheel. Yeah. Okay. That's why it runs. It's
I hope it's understandable. Yeah. Otherwise, you can come back also to Andreas later on, and then you can go in a deeper technical discussion.
Mm-hmm. Okay. Then on the right hand side we have the tailstock. Tailstock has an adaptation of MK4 as well as the work headstock. Then we have on the top of the tailstock a manual handle to open and close. On the back side, you can see this handle to adjust the clamping force. The clamping force comes out from a spring, which is inside, and with this, to turn this handle, we can higher or make it less clamping force between centers. Then on the front side, we have a cylinder correction or the taper correction. The stroke is 45 millimeters, and if we use this tailstock for, let's say, for heavy parts, you have to use both hands. We can have also a foot pedal, and then this will operate it pneumatically. And on the left-hand side, on the bottom, we see the B-axis with two separate OD grinding wheels. Our OD grinding wheels are belt-driven with power of 7.5 kilowatt, and we can have on both spindles diameter 500 by, let's say, up to 120 millimeters. So this is a lot that we can make also long parts and plunge cut grinding and so on. So this is a very good configuration for this machine.
Yes, I think we have a little bit to hurry up, or if we watch to
no. Okay, good. Control system. Yeah, this control system is a touch screen on the operating panel. We can see here the main screen, and then next to the big picture, the small one, it's the left one is for acoustic emission, and the right one is for balancing. So we have all the sensors and everything what's going on the machine on the screen on the operating panel. This is based on the Windows PC. We can have DIN ISO code programming and DXF converter and so on. But basically, we program this machine via dialog programming. That means the operator have some different screens he can switch on. On the left-hand side, you can see the technology setup. Means you put in all the technology data like feed rate, stock, what kind of technology you like to use. Plunge cut grinding, multi-plunge cut grinding, traverse grinding, internal grinding, cone grinding, all these things can be selected. And for all these grinding operations, we have more than 20 ready programmed grinding cycles available on the control system. That means the operator starts with a screen. He selects the grinding cycle. On the right-hand side, we can see setup grinding cycles. Here you can see the grinding cycle OD, cone, and plunge cut grinding for cone. Then this appears on the screen, and then the operator has to fill in on the right table all the numbers and information which the machine does not need at this moment. Size of workpiece, size of grinding spindle, grinding wheel, position of workpiece. You get also a helping hand on the screen, which some letters. You can fill in all these numbers on the table. And if you fill in all these things, the system creates a CNC program for the grinding process. So this is the normal way to program this machine. And in the middle, you have also the possibility to load up a user manual to maybe get more information about special things on the machine. Here we have a video. This is from a recent project. This is a little customized solution. This is basically a standard OD grinder, a universal OD grinder, but we have also the possibility and be able to make some customized solutions on this machine, like this here. So this is our touch trigger swiveling out for measuring the axial position of the workpiece. Then the control system knows where the workpieces are, and then we start to grind. The first OD grinding spindle and wheel is making only the OD grinding. Then we swivel to the next grinding spindle with an inclined grinding wheel, which is profiled, because we grind the profile of this end of the axle in one cut. This is like here, we have the measurement system on the OD grinding on the right-hand side, but we have one profiled wheel. Yeah, and that means that we need only the measurement system on this diameter, because the other diameter is the same. It's dressed in one cut.
Setup.
Yeah, in one setup, yeah. And then we have a special operation here. There's another diameter which is used for a sealing seat. And this is located internally of this flange. So the turning quality is not good enough. We have to grind. So we have a small grinding wheel on ID grinding spindle to make the surface quality of this diameter. So we turn as much as possible that we don't have to grind too much stock with the small grinding wheel. But this is the only possibility here. Yeah. I think this is a nice video from a W11.
Okay, and then we are jumping away from the CNC control business. We have as well conventional universal grinding machines called W11 EVO. It's a machine which is good for tool shops, for prototyping, for if you have to do today one part of this, tomorrow the part of this, only really small batches, small quantity. Sorry. But you have as well many different applications which you can grind here, internal, external, operations. It's as well a hydraulic-free machine, what is not normal on a conventional topic. Here you have, anyway, that is not a CNC control. You have complete controlled X and Z axis. Yeah, you have axis position displayed on the left side. Yeah, here you see the display, and you have an automatic retraction end of the grinding cycle. You had an automatic dressing cycle for internal and external with a dressing compensation. And you can do a single seat grinding with automatic grinding cycles for plunge cut, traverse, and face grinding. And what is important, you see the machine, it's more open. It's not covered like the CNC machine which you showed. And that's important for the well-experienced grinding people which doing really small batches. So they want to listen also to the machine. How is the sound if the grinding wheel contacts the diameter and so on, and all the features are secured here with this configuration. It's a machine bed as well. You have the Z-axis, and here you have scrapped guideways, really hand scrapped guideways in the Z-axis, and in the X-axis we have precision grinded guideways. Important is if you look to the machine concepts as well, to the W11 CNC, if you have older machines in your shop floor, perhaps you see some parallelism to our K11, K90 machines, customs machines, which many are still active at our customer sites, and that's correct. That's the base of the concepts, and that's also important, which you have to recognize. If you have an old customs K11, K90 or other types inside your production, please think about as well that we are offering to you a change of the machines. Yeah? So we take back your old machine, you get a new machine, or we also can retrofit your machine on really different ways, only mechanical, completely electrical, mechanical, new control and so on. So they are really flexible. So recognize this. Retrofit is as well possible of these machines, and we also take back machines which you don't need anymore. So please contact as well us for these topics. And you see as well, we have different spindle configurations. We have a manual B-axis, but you can swiveling it easy because it's with the air cushion support. Yeah, and we have clamping and high resolution measurement system anyway inside, so you can really positioning the B-axis on a good way. So the easiest version is only OD grinding, but you can also add 2 grinding wheels for OD and face grinding. Yeah, or you can have as well OD, face and ID grinding, and as well it's possible to have belt-driven or motorized internal grinding spindles. There,
yeah.
There you see some applications.
Here we have some nice pictures from the machine. So on the left-hand side, on the top, you can see this swiveled-in face grinding wheel. So with this face grinding wheel, you can see it also in the middle or on the bottom. We can really have a face grinding process, so 90 degrees to the workpiece. So we can have also like traverse grinding, like it. We can do it on the shaft in Z. We can do it in X, and then we can really have a good face grinding to grind the whole, not only a small seat like here. Also, we can grind the whole face plate with this operation. On the right-hand side to this picture, we can see a heavy load. This is MK6 headstock. So big chuck, big workpiece. So this is also possible on this machine. On the left-hand side on the bottom, you can see the internal grinding spindle. This is a belt-driven one, but we can have also a motorized spindle on this machine with a higher RPM range. Then some information about the screen. This is also a touch screen. We have equal to the W11 CNC, but here we can only have the automated grinding cycle and the automatic dressing cycle. Yeah, so this, and we can put in all the technology data. You can see on the picture on the right hand side, we can select the plunge cut grinding, traverse grinding. We can have also the automatic grinding cycle for ID grinding and also for face grinding. This is all things are possible because now we have controlled access. Yeah. So if we have, let's say, internal grinding operation, we have also this retracting position. If we have an internal operation, the grinding wheel goes in, make the internal grinding, then it moving out and move back in X, that you can measuring also the internal grinding system whole with a measuring system. So all these things makes it very easy and more comfortable to set up the machine. This machine cannot save programs, and this is still a single seat grinding machine. Means even if we have the automatic grinding and dressing process, we have to set up the next diameter, for example, on the shaft. If there's a different diameter, we have to select a different diameter and can grind this. So we cannot jump from one diameter to the others, yeah, and cannot save programs. This is a real conventional, modern, comfortable, conventional grinder. Here you can see, this is also a nice video. This is also done from a recent project. You can see the X positions, dressing. For example, if you have all possibilities, OD grinding, face grinding, and ID grinding, if you swivel the B-axis, and because we have an encoder system, the machine recognized that now we leave the OD and reach the face grinding operation, and then on the screen is also changing the surface, the pictures, that you can select the face grinding grinding operations. So this is also a very good advantage for this machine. So he swiveled in, and also in this case, if you swivel in ID grinding, on the screen it will change to ID grinding, that you can program the dressing and also the technology for that.
Okay. Andreas, thank you very much for this overview about our universal grinding solutions. If you have more questions, please using the function. You was really active. Thank you for that. If you have some question which you want not to share with us, with all the audience, so contact us and then asking the question there. Important is if you are watching us inside Europe, representing the WPG 7 machine in Bologna Fair next week, MexPay, from 5th to 7th. There you can discuss as well with Andreas your applications. And we have in Leipzig the Intake the week after, where we are showing a W11 machine, which you can also discuss then with our experts. I know very often also many customers, listeners, or watching us from India. In India, on the Intex, you got a chance to see already the machine. So there is also, you can go also with the team here in the discussion. And for all visitors from US, it will be only some more weeks. And then we have as well in EMAGLLC, Farmington Hills, a WPG 7 machine available. And if no more questions, I would like to thank you all for participation on this webinar. And we are looking forward to welcome you on one other webinar, or we welcome you in each EMAG site worldwide that we can discuss applications with you, discussing projects with you. We're looking forward to work together with you. Again, also thank you, Andreas. Take care. Have a good day. Bye-bye.
Thank you. Bye.